All right, now we're looking at limiting reactants. If we take a look at this problem, this is number 4 from your homework. We have sodium hydroxide reacting with sulfuric acid to produce water and sodium sulfate. And you'll notice when you read the problem, it says calculate the mass of sodium sulfate produced when 15.5 grams of sodium hydroxide react with 46.7 grams of sulfuric acid. So you'll notice you have 2 givens in this problem. And that's kind of a key to kind of figure out, okay, I have a limiting reactant problem. If I'm given 2 different givens, here I have 15.5 grams of sodium hydroxide, here I have 46.7 grams of sulfuric acid, there's a good chance that I have a limiting reactant problem. One of those one of those reactants is going to be used up. And that's basically what a limiting reactant is. If I have 2 things, 2 reactants, and they're mixed together and a reaction takes place, one of those reactants is going to be used up before the other one is. And we refer to that as limiting reactant. So let's go ahead and write out our balanced chemical equation. So I have sodium hydroxide, which is NaOH, plus sulfuric acid, which is H2SO4. It reacts to produce sodium sulfate. Sodium, again, a positive 1 charge. Sulfate is SO4, has a negative 2 charge, so it's Na2SO4 plus water, which is H2O. So, again, when I look at this, here's a reactant, here's a reactant. Sulfuric acid is a reactant, sodium hydroxide is a reactant. These are my products. So when I talk about a limiting reactant, we're talking about one of these 2 things is going to limit the reaction. And the way I'm going to do this is I'm going to set up 2 different stoichiometry problems. So I'll set up one. All right, and again, I have 2 different givens, but they're both looking for the same thing. If I look at the question, calculate the mass of the sodium sulfate produced. So I'm working towards grams of Na2SO4. All right, and my starting point, 15.5 grams of sodium hydroxide, NaOH. So that's my starting point. Now I need to make my conversion factors. So again, I'm going to start with my mole ratio. And my mole ratio is between sodium sulfate and sodium hydroxide. Oops, but I have to balance my equation first, right? So I have a chemical equation, but it's not balanced. I have 2 sodiums here. I have 1 here, so I'll put a coefficient of 2 in front of that. And now I have to put a 2 over here in front of my water. And now it's balanced. So I have 1 mole of Na2SO4 right here. And I have 2 moles of NaOH. Then I need this tells me grams is right here. I have the unit grams. That tells me I need a molar mass conversion factor for sodium hydroxide. So again, that means 1 mole. Again, it's always 1 mole in a molar mass conversion factor of sodium hydroxide. And I have to add up the mass of sodium, oxygen, and hydrogen. There's just 1 of each. So 23 plus 16 plus 1 gives me 40 grams of NaOH. And then I need a molar mass conversion factor for sodium sulfate. So 1 mole of Na2SO4 has a mass. And now I have to add up the mass of 2 sodiums, 1 sulfur, and 4 oxygens. And that gives me a mass of 142 grams of Na2SO4. My conversion factors are running into each other a little bit. So now I can go ahead, I have all of my conversion factors that I need. I can go ahead and plug those in. So I will choose this one first. 40 grams of NaOH, 1 mole of NaOH. Again, I want this unit down here. Add another conversion factor. Now I want moles of NaOH, so go over here. 2 moles of NaOH to 1 mole of Na2SO4. 2 moles NaOH to 1 mole of Na2SO4. And then my last conversion factor is right here. Again, 1 mole needs to be on the bottom, 1 mole of Na2SO4. So that moles of Na2SO4 can cancel out. And then 142 grams of Na2SO4. All right, so now all I have to do is solve mathematically from there. So 15.5 times 142 divided by 40 divided by 2. And that gives me an answer of 27.51 grams. Don't know what happened there. 27.51 grams of sodium sulfate. All right, so I've done one stoichiometry problem, and I've come up with a mass of sodium sulfate, which is what I was asked for. But I also have 46.7 grams of sulfuric acid. And now I have to do a second problem for that one. So I'm going to set up another dimensional analysis problem working towards the exact same thing, grams of Na2SO4. This time I'm going to start with 46.7 grams of sulfuric acid, H2SO4. All right, so now doing a whole other problem. I need to pick out my conversion factor. So I need a new mole ratio. Some of these conversion factors I'm going to use, I'm running out of space, so I'm going to erase some of them. So I'm just going to erase my mole ratio here. And I will erase my sodium hydroxide molar mass conversion factor. Put my 4 back in there. All right, so now I need a new mole ratio, this time between sodium sulfate and sulfuric acid. So back to my balanced chemical equation, 1 mole of Na2SO4 and 1 mole of H2SO4. All right, and then I need a molar mass conversion factor for sulfuric acid. I still need a molar mass conversion factor for sodium sulfate, but that's right there. So I'm just going to use that one again. 1 mole of H2SO4 has a mass, so I have to add up the mass of 2 hydrogens, 1 sulfur, and 4 oxygens. And that gives me a mass of 98 grams of H2SO4. All right, so again, now I have all of my conversion factors. I can go ahead and solve. So, or sorry, plug in my conversion factors. I want to get grams of H2SO4 down here, so I'm going to choose this conversion factor right here. 98 grams of H2SO4 in 1 mole of H2SO4. Then there is 1 mole of H2SO4 in 1 mole of sodium hydroxide, NaOH. Oh wait, we're not doing sodium hydroxide, excuse me. I erased my whole line there. If we look over here, it's not sodium hydroxide, but sodium sulfate. So 1 mole of Na2SO4. And now my last conversion factor right here. Again, I have to flip this one over, so I have moles of sodium sulfate and 142 grams of sodium sulfate. Okay, so now that's done. Now all I have to do is solve mathematically. So 46.7 times 142 divided by 98. And that gives me 67.67 grams of sodium sulfate. So now I have two different answers, and I have to think about what this means in terms of a limiting reactant. So if I mix together 15.5 grams of sodium hydroxide with 46.7 grams of sulfuric acid, and they went through a neutralization reaction, because this is an acid and a base, they would produce how much sodium sulfate? And the correct answer to this question is 27.51 grams. And the reason why is after 27.51 grams of sodium sulfate is made, the 15.5 grams of sodium hydroxide would be used up. All of the sodium hydroxide that you put into this reaction has been used. It's all gone. There's none of it left. And this is how much sodium sulfate has been made. If I had 46.7 grams of sulfuric acid with an unlimited amount of sodium hydroxide, then I could make 67.67 grams. But all of my sodium hydroxide was used up over here making this. So whenever I do a limiting reactant problem and I have two givens, the smaller of the two quantities identifies the mass that would actually be produced of my product, in this case, sodium sulfate. It also identifies what the limiting reactant is. So this here is my limiting reactant. And we call it a limiting reactant because that's the one that limits the ability of the reaction to take place. If I mix those two quantities together, there would still be sulfuric acid left over. But it can't react because, again, the sodium hydroxide has been used up. And that's the whole idea of a limiting reactant problem. So this is the quantity, and my limiting reactant is sodium hydroxide, which means that the other reactant is my excess reactant. So the excess reactant would be sulfuric acid, H2SO.